Hello students, hope you are doing well. In this video, we are going to discuss campus design consideration part 1 of unit 3, designing basic campus and data center networks for the subject enterprise network design of BV 7th semester IT, University of Mumbai. This lecture campus design consideration is divided into part 1, part 2 and part 3. In part 1, we cover campus design consideration. In part 2, environmental characteristics and consideration. And in part 3, infrastructure devices characteristics and consideration. So, in this lecture, we will discuss designing an enterprise campus, network application characteristics and consideration, peer-to-peer application, client local server application, client server farm application, client enterprise edge application, and the application requirements for all these kinds of applications. Designing an enterprise campus. The enterprise campus network is the foundation for enabling business application, enhancing productivity, and providing a multitude of services to end users. There are three characteristics it should be considered when designing the campus network. First is network application characteristic. The organizational requirement service and application place stringent requirement on campus network solution, for example, in terms of bandwidth and delay. Next is environmental characteristics. The network's environmental characteristics include its geography and transmission media use. The physical environment of building or buildings influences the design and do the number of distributions of and distance between the network nodes, including end user, host, and network services. Other factors include space, power, and heating, ventilation, and air conditioning support for the network devices. Cabling is one of the biggest long-term investment in the network deployment. Therefore, transmission media selection depends not only on required bandwidth and distances, but also in the emerging technologies that might be deployed over the same infrastructure in the future. Third characteristic is infrastructure device characteristic. The characteristic of network devices selected influence the design. For example, they determine the network's flexibility and contribute to the overall delay. Trade-offs between data link layer switching based on media access control addresses the multi-layer switching based on network layer addresses, transport layer, and application awareness need to be considered. High availability and high throughput are the requirements that might require consideration throughout the infrastructure. Most enterprise campus design use combination of data link layer switching in the access layer and multi-layer switching in the contribution and core layer. Network application characteristic and considerations. The network application characteristics and requirement influences the design in many ways. The application that are critical to organization and the network demands of these application determine enterprise traffic pattern inside the enterprise campus network, which influences bandwidth uses, response time, and selection of the transmission medium. Different types of application communication result in varying network demands. The the application communications are peer-to-peer, client local server, client server farm, and client enterprise age server. So let us discuss first peer-to-peer communication. In case of peer-to-peer communication from the network designer's perspective, peer-to-peer application includes application in which majority of network traffic passes from one network edge device to other through the organization's network. So here this figure illustrates the same thing. Typical peer-to-peer application includes the instant messaging. First thing is instant messaging. After the connection is established, the conversation is directly between two peers. So here one and another peer after the connection is established. Now, second is IP phone calls. Here IP phone calls. So two peers establish communication with the help of IP telephony manager. However, the conversation occurs directly between the two peers when the connection is established. The network requirement of IP phone call are strict because of the need of quality of services treatment to minimize delay and variation in delay, that is jitter. Quality of services already we have covered in quality of services consideration in LAN switches. Now come to file sharing. This is another job of peer-to-peer network. File sharing, some operating system and application require direct access to the data on the workstation. Then video conferencing subsystem, this is very common nowadays. Video conferencing is similar to IP telephony, however, the network requirements are usually higher, particularly related to bandwidth consumption and quality of services. So this is a simple diagram for peer-to-peer communication. Client local server application. Historically, clients and servers were attached to a network device on the same LAN segment and followed the 80-20 workgroup rule. This rule says for client server application, 80% of the traffic is local to the LAN segment and 20% leaves the segment. With increased traffic on the corporate network and relatively fixed location for users, an organization might split the network into several isolated segments. Here in this particular diagram, two isolated segments are shown. Of these segment has its own servers known as local servers. Here two local servers are also marked for its application. In this scenario, servers and users are located in the same virtual lane and department administrator manage and control the servers. The majority of department traffic occurs in the same segment, but some data exchange to different virtual LAN happens over the campus backbone. The bandwidth requirement for traffic passing to another segment typically are not crucial. For example, traffic to internet goes through a common segment and has lower performance requirement than traffic to the local segment, because inside local segment a huge communication is going on, and for the different segments inter segment communication, it requires very less communication. Client server farm application. Client server farm application, this is the model diagram for client server farm application. So large organizations require their use to have fast, reliable, and control access to critical application. Because high performance multi-layer switches have an insignificant switch delay, and because of reduced cost of network bandwidth, locating the servers centrally rather than the work group is technically feasible and reduce support costs. To fulfill these demands and keep administrative costs down, the servers are located in common server farm. So this is server farm. There are varieties of server located in that server farm. And using a server farm requires a network infrastructure that is highly resilient, providing security and redundant, providing high availability. And that provides adequate throughput. High-end LAN switches with the fastest LAN technologies such as gigabit Ethernet are typically deployed in such an environment. In large organization, application traffic might have to pass across more than one wiring closet. LAN or VLAN to reach servers in the server farm. Client server farm application apply the 2080 rule, where only 20% of the traffic remains on the local LAN segment and 80% leaves the segment to reach centralized server, the internet, and so on. Such application includes organizational mail server like Microsoft Excel, common file servers like Microsoft and Sun Solaris, common databases servers for organizational application like Oracle and MongoDB. Client enterprise edge application. This is the diagram which shows client enterprise edge application where building access, building distribution, campus core, server farm, and enterprise edge. So this is the modern architecture for that. Client enterprise edge application use servers on the enterprise edge to exchange data between the organizational and its public servers. The most important issue between the enterprise campus network and the enterprise edge are security and high availability. That is very important thing in any network, actually not in this, but here it is very important the network is secure, and second thing, it is available whenever we are going to access it. No bandwidth will affect the availability of server. Data exchange with external entities must be constant operation. Application installed on the enterprise edge can be crucial to organization and its process flow. Therefore, any outage can increase the cost. Typical enterprise edge applications are based on web technologies like application types such as external mail and DNS servers and public web servers can be found in any organization. Organizations that support their partnership through e-commerce application also place their e-commerce servers into the enterprise edge. Communication with these servers is vital because of the two-way replication of data. As a result, high redundancy and resiliency of the network along with security are the most important requirement for these applications. Now come to application requirement. This is the table which includes parameters such as connectivity type, total required throughput, high availability, total network cost. Peer-to-peer, client local server, client server farm, and client enterprise edge server. In case of peer-to-peer, it is divided into shared network and switched network. When we are using shared connectivity type, total required throughput is very low, high availability is also low, and total network cost therefore goes down. In case of switched network, switch connectivity type, The total required throughput is medium to high. High availability, again, it is very low. Therefore, the cost is also low. Now come to client local server and other higher end technologies use the connectivity type as switched. Total required throughput is medium and high availability is also medium because client local server is there. Like multiple local servers are located, and therefore the cost of this implementation is also medium. Client server form, it uses switch technology for connectivity and total required throughput is high and availability is also high and total network cost therefore increases. Okay, so this is also very high. To overcome this problem, actually we have tried to overcome peer-to-peer and client local server problem in this client server form and create the biggest server form. To overcome this problem, client enterprise age servers are coming. So here connectivity type, again it is switched and total required throughput thereby medium and high availability is high. So due to this minimum or medium throughput, the network cost is also medium. Now let us discuss each parameters like connectivity, throughput, high availability and total network cost one by one. So what is connectivity requirement? The wide use of LAN switches at layer 2 has revolutionized local area networking and has resulted in increased performance and more bandwidth for satisfying the requirement of new organizational application. LAN switches provide the performance benefit by increasing bandwidth and throughput for the workgroup and local server. So what we need to do? Throughput and availability. Using shared media for peer-to-peer communication is suitable only in limited scope. Here in this particular diagram. Okay. This is only suitable for limited scope. Why? Typically, when the number of client workstation is very low, for example, 4 or fewer workstation in small home offices. Now come to throughput. The required throughput varies from application to application. An application that exchanges data between users and workgroup usually does not require high throughput network infrastructure. However, organizational level application usually require high capability linked to the servers, which are usually located in server farm. Peer-to-peer communication, especially in case of frequent file transfer, could be intensive and the total throughput requirement can be high. Fine. Application located on servers in the enterprise age are normally not as bandwidth consuming as application in the server form, but they might require high availability and security features. Now come to high availability. Connectivity we discussed, throughput we discussed, now come to high availability. The high availability of the application is a function of the application and the entire network between a client workstation and a server located in the network. Although the network design primarily determines the network's availability, the individual components mean time between failure. That is MTBF, very important matrix. Okay. It is a factor. Redundancy is the building distribution and campus core layer is recommended. Now come to total network cost. Depending on the application and the resulting network infrastructure, the cost varies from low in a peer-to-peer environment to high in the network with redundancy in the building distribution, campus core, and server farm. In addition to the cost of duplicate components for redundancy, cost includes the cable, routers, switches, software, and so forth. This campus design consideration part 1 is completed. Here we have discussed designing an enterprise campus, network application characteristics for peer-to-peer application, for client local server application, for client server form application, and client enterprise edge application. And based on these discussion, we have concluded different application requirements. In next video, we will see the campus design consideration part 2. Thank you. Bye bye.